Hi, everybody. We'll start in a minute or less. Yes, this is my title slide. So, hello, everybody. We're going to speak about C++ pitfalls and sharp edges to avoid. And maybe you heard about that C++ may have some pitfalls and sharp edges. And I'm sure that you are here in order to help your colleagues avoid these, because we do not do any bugs. So this is the topic. A few words about myself. I'm a lecturer at the Academic College of Tel Aviv-Yafo and Tel Aviv University, co-organizer of the Core CPP conference in Tel Aviv, which would happen on October if you want to submit that talk, if you are adventurous enough. A trainer and advisor, and I had many years in the industry. Some of the bugs that I would present are proudly mine. This is Cippi. She's sitting here, so maybe for the recording and for anybody who was not here when we started, Rainer Grimm is a dear colleague who is handling ALS. And he gives us insight and inspiration because he's still contributing to the C++ community, publishing, giving lectures in online and online talks. So I'm sending from here our appreciation to Rainer. Should we check for null? We had this talk, right? And the answer is, okay, it depends. Well, the slide is a bit misleading. The slide is a bit lying because the title was not should we check for null, the title was should we check for null here? So maybe not here, but yes, we should check for null somewhere, because if we do not check for null anywhere, then null would come in and there will be bug. So either it's a contract, it's an assert, it is checked when you go in, it is checked when you are going to do something with this pointer, because yes, pointers might be null. Pointers might be also uninitialized, but yeah, we will try not to make them like as uninitialized. We cannot check if a pointer is uninitialized, but we can check if it is a null. Bugs. Yeah, this is AI generated. Seems fine. Where do they come from? Why do they come? Let's tell you a story about a bug of mine. Back in the old days, I used to blog post, write posts when I had a bug. Today I'm too lazy for that, but I advise my students to do that. I mean, if you want to remember something, write about that, because otherwise, you know, you'll forget. And this is the way that I just recalled that back in 2011, I had this bug that I was going to tell you about. And the bug was waiting quietly to come up in a conference. So this is a story of a bug in production. On 2nd of January 2011, there was some crash in a system that I was in charge of. And the crash happened again and again, and we started to check what is the problem, and we realized that there is a timer that is getting rescheduled again and again. We can't find in the code why, and the system starts again. So, okay, somehow we handle that in production, but we want to check what is the actual problem. During the day, we understand, okay, maybe there is a problem with the timer library that you are using. And apparently, at the same time, there is something being published around that there is a problem. Another company, who I would not say the name, it is named after a fruit, had the same issue and some crashes. So we said, okay, it's not only us, maybe there is an issue with the timer. The issue is not with the timer, but we couldn't find out what the problem was, but on January 3rd, it just disappeared. Everything is fine. We can continue. But then we realized that there is a problem, and the problem was that at a certain point, we give a function to the timer, a callback. the callback should return a value of whether it's exceeded or not. And for some reason, this function didn't return a value. You can write a function, which is not a void function. It doesn't return value. It's not a compilation error. I mean, it should be a warning, but probably this warning was off for some reason. Now, usually what happens is it just takes the last value in the proper register and uses that as the return value. And probably the actual return value was saying, reschedule the timer, or there was a problem on January 2nd. So, okay, we found a problem. Now we return a value from this timer, from this callback, and we decided to do something else. I don't know if anyone here is doing that, but we started a new practice, which was, okay, we have a problem. I mean, we fixed that, but we feel that maybe there are things that are related in our system to the current time, even though it was not related to the current time. The current time was just a trigger for the bug. We started testing 30 days ahead. Like, we set a date for 30 days ahead, and we have a system checking in test, the entire system test, with the date of 30 days ahead. So if we have a problem, we have 30 days. We felt that this is enough. We can run 60 days ahead. But and that was nice. I mean, that's an idea. I don't know if you are doing that. Essence and accident in software engineering. This is a paper by Fred Brooks, 1986, where he argues that in a decade from 1986, there wouldn't be any significant change in the way that we do programming, the way that we do software, that will change productivity in order of magnitude. And it is maybe true till these days. Maybe AI will change things. And the argument is that the tough stuff in software engineering, in writing code, is not the accident. The accident is something that maybe you can improve. The accident is the way that we write code, the way that languages work. The essence is the actual product. It's the requirements, is how things are engineered into our code. When we talk about bugs, we can distinguish between bugs that are essence, bugs that relates to essence, and bugs that relates to accident. For example, the nature of the essential bugs is conceptual. Something conceptual is wrong in the system. The essence of accident would be technical bugs, something wrong in the code. By the way, the timer thing, is it essence or accident? It is accident, for sure, right? The function should return a value, and we forgot, we didn't take care of that, and that's an accident. It's not that we didn't realize the actual requirements. The source of essential might be misunderstanding, misconception, omissions. The source of accidental might be false in implementation. And it relates to the actual errors, which would be logical errors or implementation errors. Essential bugs would be requirements, misunderstanding, complicated state management that is not reflected in the actual system correctly. Faulty conceptual models, like we didn't model the actual thing in the code. It's not a bug in the way that we implemented. We didn't get things right. Essence is complicated. Understanding, foreseeing possible inputs, combination of inputs, defining system behavior, defining fail-safe. What should happen if, okay, there is a problem, or the car should slow down and try to move towards the pavement, but not going on the pavement. Setting a safe path from bad state to fail-safe. And by the way, I believe that this would still hold us in the industry for some time, while AI would deal with the accident part. I mean, the AI might not deal with this part quite well for a few years or more. Ending the essence means clear and actionable requirements aligned with actual user, system needs, understandable. I mean, the requirements should be good. a good model architecture, and effective validation and testing. So we can actually check that the system does what it should do. Accidental bugs are other things, like typos, wrong variable name. By the way, in Python, wrong variable name, yeah, it can go to production if we didn't run any lint. In C++, wrong variable name, would it be a compilation error? No, because maybe there is another variable with that name. I mean, we meant this variable, but we actually wrote the name of the other one. If there is a proper variable, oh, the antivirus now decided to pop up. I should kill it. Okay, so typos, like for example, single equality instead of double equality. Semantic misuse. Semantic misuse means that, yeah, we thought that we're using the right thing, but it's not the right thing because it doesn't work as we think. And again, it's not coming from requirements, it's the way that we use the language. Conversions. Overflow and underflow, either if they are undefined behavior or just overflows the actual value. Floating point errors, if you want to see Nolan's, Eddie's talk from Core C++ about all that you need to know about floating points. Ownership and data management, mutating data, which is owned by another thread, updating a copy instead of the original, etc. Using uninitialized data, using dead resources, dangling pointers, dangling references, invalidated iterators, moved from objects, which are not exactly dead resources, but they are moved from object. Off by one errors, out of bounds access, wrong item accessed. I mean, it's not out of bounds, it's just the wrong index. Resource leaks, threading on concurrency, bad API use. We didn't read the contract. We didn't realize that, oh, the API doesn't work like that. Or we switched the arguments. How can we avoid switching arguments? Use maybe safe types. So the types are different. And as long as the types are different and they are not convertible, then you cannot switch. Critical inefficiencies might also be an actual bug. Whoa, that is frightening. I mean, maybe we should call off. I don't know. What can we do? I mean, so many potential bugs. So luckily for us, there are safety nets. And the safety nets are the things that in a way help us with most of the things we just went through. Like compiler warnings. I'm not starting with compiler errors because compiler errors, okay, there isn't any code. But once you have running code, still if you add any compiler warning, stop. Something is bad. You should make sure that you have no compiler warning. Minus WL is not enough. Minus WL, I think, maybe even doesn't warn on a function that doesn't return a value, which is not a void function. So, for example, if we have accessing the reference null pointer, I mean, the compiler is able to see here, without even static code analysis, that PTR is assigned to null PTR, and on the next line, we try to dereference that. And the compiler will not warn, even with minus WL and minus W extra. Now, okay, yeah, we will get that, I guess, with static code analysis, but can we get that with warning? And the answer is yes, there is a proper warning, minus W null dereference. Let's use it. Let's add it. Can the compiler always find it? No. But in cases that the compiler can find it, why not use it? So I would recommend this list of warning, which is quite exhaustive. Yeah, but if you miss one and then you miss an error, maybe I should put all these, because minus W all is a bit misleading. It's not all. Even minus W extra is extra, but you know, there is extra above the extra. And this is not the entire list. The problem is that usually we do not put the entire list because of legacy code. Because, oh, but we have legacy code and some warnings are okay. We know that they are fine and we cannot go and change the code because maybe we'll introduce new bugs, maybe we don't have time to do that. So at least for new code, in a way, and maybe we can go back and fix old code when we can. Static code analysis. Static analysis is quite good. I mean, they do find things even between compilation units. Runtime sanitizers. Testing. We cannot avoid testing because testing is the thing to find essence bugs. Essence bugs would not be found with static code analysis or warnings. The compiler, the static analyzer doesn't know that we do not meet the requirements. What is happening today? Anybody here from a cafe? I want to remove it. It doesn't let me usually. Okay, so unit tests, component tests, integration, system testing, fuzz testing, make some random things using proper fuzz testing utilities. Best practices. Best practices are a tool. I mean, if we comply to best practices, then we will avoid some of the bugs, like, for example, dereferencing null or leak. How can we avoid leaks? What is the best practice to avoid leaks? Use smart pointers. If we use smart pointers, at least for the part that we are using smart pointers, we would avoid leaks. So there was a talk on best practices. In some cases, they collide, or you don't want to follow, like maybe exception guarantee, because maybe it will make problems with rule of zero. But eventually, if we take into account best practices, we'll have less bugs. Code review is a must. AI reviews. Do you do AI reviews occasionally? Ask the AI, what do you say about my code? Now, it's another thing, fix my code, don't do that. I see students using AI for writing their code and then using AI for fixing the code. And when you use Copilot agent, you just need to press the green accept all, right? No need to read that because it's AI. The thing is smart. So no, even if you use AI for writing code, read what is given for you. Anyhow, AI reviews, pair programming, all these techniques are in order to avoid bugs. Coverage management. Let's make sure that all code inside is meant to be used for a certain requirement. Otherwise, if we have code that is not related to any requirement and there isn't any test that tests that, then this is redundant code. Protective programming. When we talk about protective programming, we talk about contracts, asserts, checking something that, yeah, it should be good here, but I'm not sure, so let's check. And continuous integration is also something valuable because we will find bugs earlier. We'll run the test again and again. But when the safety nets doesn't work, we are in problem. Let's take a look at a few examples where safety nets do work. Like, for example, this one. Do you see the problem? We humans may not see, but you know, the proper tools will see it. The semicolon, there is a, what is this semicolon there? But yeah, a semicolon got in, and eventually it means that we will always print done. In this case, it doesn't hurt us, but it might be that we do something that we shouldn't do. If I run with a proper compiler warning, like -w or -w extra, I will get a warning on that, okay? It might be that I don't want this warning because, oh, I do mean that, but there is another way to do it. I mean, you do want that, so maybe take the other statement and put it not in a curly braces. I don't know. Anyhow, yeah, we got a warning. That's good. Static code analysis here, clung tidy. Warrants about that. That is good. Okay, so let's use the tools to avoid such bugs. It's a very tiny bug. I guess that you are saying, okay, we are not doing this bug, right? So I actually had this bug, okay? It was not in C++, it was in Java. Yeah, you can write bugs also in Java. And by the way, the bug in Java, the semicolon, created a memory leak. How come? because in the if there was a statement that sent something to be released, and it was not released because what happened there is you did the if, and then you added something which you shouldn't add. Anyhow, the semicolon created an actual, by the way, bug in production. Now, I think that back then Java didn't give a warning on that, but it is from 2010. But static code analysis could. And when we added static code analysis, just to check whether find bugs was the tool back then, whether it would find it, it did warn on that. And it was a real bug in production. Another code example. What's bad here? What's the problem? Can you see? There is a very simple class point, and you want to initialize the point with 1 and 2. So the point would be initialized with 2 and 0. The 2 would go to the x, and the 0 would go to the y. And the reason is that we are calling the comma operator that returns the last element. The 1 is being waived, and we just take the 2. And since we have a constructor with default arguments, which is a sin, I prefer not having functions with default arguments. I, by default, prefer overloading. Because I don't think that here the aim was to support creating a point with only with only an x. I mean, there isn't any point with that. It's pointless. But we do support that. I mean, the API supports something that we didn't want to support. So this is bad API, but this is how it is. And then the problem is that we actually, instead of using curly braces would work. I mean, it's a complicated language. Curly braces is fine, but these would create, even though the safety nets would work, you would get compiler warning. You would get, okay. But if you turn it off, then yeah, you may get the wrong point, and that's a problem. Static code analysis also points at that. Okay, that is good. So apply the tools. But as I said, safety net doesn't always work. So code may look fine or actually be fine. And it might be that no compiler warning, no static code analysis warning. Some compiler static code analysis warning are suppressed or disabled because we get too many false positives. So we say, oh, we know what we are doing. And then when we actually don't know, or there is a bug, we can't find it. Code may cause undefined behavior. It might be that the compiler and static analysis cannot point at that. And not all issues are detected in testing because testing only tests what we test, which is the coverage. Even if we have 100% branch coverage, it's, okay, we went through all branches, but not through all combinations of possible inputs, which we cannot do. Okay, that's an issue. Let's take a few more code examples. What's wrong in this piece of code? Which is working, compiling, and I will ask you when you find the issue whether it is undefined behavior or not. The order of evaluation in the call to foo is unspecified. So GCC will give us, depending on, I guess, the proper flags. GCC gave me 2 and 1, and Clang gave me 1 and 2. Now, it may work. I mean, when I say it may work, might be that I passed the test, okay? And then I just switch compiler, or just switched compilation flag, change my optimization level. I don't know, something changed. What should I do? Retest. Always. You change something, you build again, after a new build, certification. I mean, things change just because we rebuilt with another compiler, with some certain other flag. Things may change. Now, it is not undefined behavior, it's unspecified, and the problem is that in a way, it might be that we actually rely on the order of evaluation, which is actually unspecified. Safety nets, nothing. At least with what I checked. It might be that at a certain point of time, or with a certain tool that you use, it might be that you'll get static code analysis warning. I didn't get. What can go wrong here? So I will tell you what we see in the code. Maybe you know this example. It's not my example. I'll give you the pointer to the actual source of that. So we have a function called, what is the name of the function? Get all default. Do you see the function name is get all default? And the function should return a value from a map, or if the key is not in the map, then a default value that we provide. So we call get all default. We call it with the map, the key, and the default value. And it looks for the key in the map. If it doesn't find the key, then it returns the default value. What is your vote on the actual problem that may appear here? Maybe the map can be empty, and that's a problem, maybe. Maybe it's you may get dangling reference. Maybe there is some inefficiency, or code is too generic. Yeah, the return by a reference might be a problem, even though I do return something that I got as an argument. I mean, I'm returning something that I got as an argument, so it should be alive. The problem is that, yeah, it should be alive, but then when I get it by ref, the user might hold the ref, because the user says, okay, I got back a reference, let's hold the reference. Instead of copying it, I don't want to copy. And then in the next statement, let's use it. And it might be that this reference that I just get was the default value, and it was sent actually as a temporary, as an R value reference. So the problem is a dangling reference. And this example comes from, by the way, here's the example. Okay, I call get and default. I take it as a ref, just in order to be more efficient. Efficiency, in some cases, is a problem. And then when I use it, it's actually a dangling reference. I think that you know that, right? By the way, analyzer, address sanitizer would find that, okay? If I run it with address sanitizer, I will get on it. Or run things in testing with address sanitizers. It comes from a talk by Louis Brandy from Facebook, 2017 CppCon, great talk. 10 recurring bugs in Facebook. Do you have recurring bugs? Recurring bugs are bugs that you fix, and then they come again, maybe in the same location, maybe in another location. What should you do with recurring bugs? Give a talk, okay? So at least in your company, at least, you know, educate others that, oh, we should be aware these bugs are recurring. You can write a comment saying avoid this bug. In exploration of real-world issues, I published this survey. I will give you at the end, again, the QR. You can take it now or later. Asking people, asking colleagues, asking companies that I work with, can you point me at bugs that you encountered and you want to share? I got a few. Let's take the first one. What is wrong here? So we have an average function. It's not the actual code. You know, I just bring the bug, and then I can play with that with any code that I want. So we have an average function. The function calls accumulate. It might be that we do not have any. The count is 0. Okay. So if the count is 0, then we just want to do something. What's the issue? Throwing an exception is fine. Hard to see, right? We actually do not throw an exception. The problem is here. It's a real scenario. Somebody submitted as, oh, this happened to me. They actually forgot the word throw. And it compiles. I mean, you create some temporary. Maybe you get warning with a proper warning level or flags. Maybe static code analysis. Anyhow, this was code in code review, okay? Code review is good. I mean, better than catching that in production. So aiming for 100% coverage in testing, suppose that it would not be caught in code review. Can we catch it in testing? Only if we test error cases. If you do not test error cases, the error cases will appear in production. I mean, the best place to test things is in production because there you get the actual thing, right? Not anything that you just imagine. But better to try to imagine things ahead. What's the problem with this code? So the story is, we add in A, which is the base class, we had a function called foo. And the function was const. And we had the same const being override in B. And then for some reason, A needed another implementation, the non-const foo. So we added the non-const foo in A, which may happen. I mean, somebody says, oh, okay, in some cases I need to call a non-const. Okay, let's add the non-const and we want to do something else. So we added that. And now? The behavior of main has changed. Because before we had the second foo, the non-const foo in A, before we had the non-const foo in A, then when we call foo, we reach the B foo. Why? Because it's the same function being overridden and the compiler sees that, okay, it has to use the virtual table and it is being delayed to runtime and then actually we are a B and we call foo of B. But once we have, even though it is virtual, once we have the non-const function, then A star is non-const. So the compiler, we still go through the virtual table here, but we are looking for the non-const function, which is the foo of A. That's an issue. I mean, you may say, no, I meant for that. No, you did not. I mean, don't write code like that. So you don't get compiler warning. Static code analysis didn't catch this exact case. Maybe other tool. I mean, static code analyzers do improve. But as long as they improve, usually our thing is to suppress the warnings. I mean, they give more warnings, but then we suppress them because we got too many warnings. There wasn't a test case for this error and it was discovered in production. I mean, not this exact foo. They didn't have a foo function there. It was a very similar scenario. And they just added the non-const override version to handle that. Other polymorphic issues. I'm not sure that I will go through the code examples, but they are in the slides. Different default value in virtual functions. I have a virtual value. I have a default value for an argument in the base and a different default value in the derived. Oh, that is bad. The default is being selected at compile time. So you actually reach the function of the actual type, but with the default of the base, even though you reach the derived function. Because the default value is being processed or used at compile time. Don't do that. Would you get static code analysis warning? Depends on the tool. Just don't do it. Forgetting virtual destructor, forgetting adding virtual on base class destructor, calling virtual function from constructor or destructor. If I call a virtual function from the constructor, assuming that, okay, I call draw from shape, probably I will see my rectangle. No, you will not see your rectangle. Calling virtual function from constructor or destructor is not polymorphic. We know that. We still do that in some cases. And the problem is that it is allowed. And in some cases we say, yeah, we know what we do. It's fine. In this case, this is what we meant. Yes, but it's a code smell because then you will do something that you did not mean. And it is better just to say, no, we do not allow that. Maybe even with a proper static code analysis rule. Object slicing. I'm assigning a B to an A. I'm assigning a B to a B. Can there be any object slicing when I assign a B to a B? Yes, if the B being assigned to is not considered B at compile time because it's a pointer to a B, being represented as A star. So I'm calling the assignment of A. Do we have such a code? No. Can we have it? Yes. Usually the problem is that the things that we know we wouldn't do, when it's actually there, we cannot see it. You know, we just go through code review, it looks fine. If we have a pointer to an A, getting assignment of a B, even if the pointer points to a B, unless you implemented the virtual assignment operator, which doesn't work quite well. So slicing is an issue. How can we avoid slicing? Code review, testing. I mean, if there is slicing and it will cause a problem, the test should handle that. The test should find it. What's the problem with this code? We have a cow screw. The cow screw is a struct with a virtual destructor and a shared PTR to its colleague. I mean, any cow's agent needs a colleague. They come as pair. And then we have a cat in a hat, a cat in the hat, and we have thing one and thing two. And in main, they are grouped together. We create the cat, we create the thing one, thing two, and then we align them. We just say, okay, cat one, your colleague is cat, your colleague is thing one, your colleague is thing two, and thing two, your colleague is cat. And you all see now that we have a circle which creates memory leak. Did you get a memory leak sometime with shared PTRs? I got. I mean, usually it is because we have A and B and C, and A alls B with shared PTR, B all C, C all D, everything is fine. Till somebody needs D to hold A, which is fine as well, but he didn't check that he is closing a circle. And then we have a leak, and then we try to see why, and we find it, and we replace something with a weak PTR. Would we see that with static code analysis? Might be. When I had that, I didn't. The static code analyzer didn't find this bug. We found that in testing. No compiler warning in this case. Other sanitizer may catch that. Why? Because when the program ends, there is memory which is not released. Break the cycle with weak PTR. What's the problem with this code? Okay, let's explain the code. It's quite long. Okay, we have a write number to binary file. Okay, we want to write a number to binary file. So we get a file, we get some input, which we will check in a moment. What is this input? And we get a Boolean is binary. The is binary is referring to the previous argument, the input. Okay. We first static assert that this is trivially copyable. We don't want to copy something from the char star into memory location if it is not trivially copyable. Then we say, okay, it might be that the input is text. It is char star. Maybe it is digits as text. But maybe it is a binary, like, you know, binary as int. Okay, we got int here. So we say, okay, if it is binary, then let's take output and point with output to input. And okay, output now represents the input, which will go to the file, and the person who uses the file, I guess, knows the actual binary format, I hope. Anyhow, we then have an else, in which case we say, oh, it's not binary. Okay, if it is not binary, then we would use stream. We would create a temporary t-value in order to write into the value, okay? The value is the same type of, it is all templated on the actual type of the number. Okay, let's write something, and then make sure that we can, let's reinterpret cast into the actual type, and write it to the file. When we write it to the file, we don't really care whether it is binary or text, because now it is just a buffer. It fits into a slide. And now, in a way, we lost the ability to read code, right? In the past year, did you lost that? Oh, we have here safety and security issues and size issues, but I'm looking for the bug that is in the slide. I mean, yeah, there are many issues. And again, it's a snippet created artificially in order to bring up the actual bug. Yeah, t-value is local. The problem is that t-value is local, okay? T-value is being dead at the curly braces. And then we have output which is pointing, after the reentry of the cast, to a value which is on the stack, but unwind. I mean, you know what? Most probably it would work. I mean, unless something else already writes something to the stack. You know what the issue? It may not work. Maybe it would work now. Maybe somebody else would come to the function, change something very small, and now it doesn't work. But you know, it passes the test for some reason, because the test only checks the binary case, not the text case. But then in production, maybe we'll have the text case. Anyhow, that's an issue. I mean, we are reading from dead stack variable. That was an actual error, okay? What was actually caught by static analyzer. We do things like that. So yeah, we need static analyzer, because otherwise, and testing and code review, it's not the exact same thing, okay? But I'm just, artificially building something that somebody just reported. By the way, shadowing. Shadowing is not the exact same thing, but shadowing can be, let me show you an example of shadowing. I don't know if it is a bizarre example. You may say, no, we write such code. So let me show you this example. Okay, we have here main. In main we have x. We have 2 pointers. And then we point with one to x, and we point with the other to x. Are they the same x? No, because there is another x just introduced in between. Is it valid? Apparently it is. It's not compilation error, it's not undefined behavior. Apparently the rule is that as long as there isn't any shadowing variable, the previous one, the global one, is still the one that we can point to or use. Once a new one is introduced, then at that point you have a new one. Should we write just such code? No. Should we fire the person? Sure. But suppose that we have such code somewhere. So if it works, great. But we need to make sure that it works. Or, of course, change it. And the way to make sure that it works is static code analysis, code review, testing. Widget. What's the issue here? We have string in widget, which is the natural thing to do with a widget. And we have a get string which returns a reference. Yes, we see that. And we have a function that gets the reference to a string and a widget and prints both in a way. Then in main we create a widget and we call func. Now I'm trying to be fair here, and this is something that we learned already. Yeah, order of evaluation, but maybe not only order of evaluation. If let's assume that getString was sent first. So let's assume that we are with a compiler that evaluates getString first. So we get a reference to the string. So the reference is being sent to the other side. But then the move is being called and invalidates or creates the widget to be moved from, and then the actual string that is inside is moved from. Oh, you say when we do the stud move and we call func, it depends on, but widget is using rule of 0. So if I get it correctly, I think that when I move, then I would go through the move of the string. Yeah, exactly. It would use the move constructor of the widget, which is the default move constructor, which would go through the move constructor of the internal string. Eventually, the problem here is that we have a dangling reference, or a reference to a moved from object, okay? That is correct. Maybe short string optimization would work here, exactly, yes. So other sanitizer would not find it. But there is still a bug because the string might be long at a certain point, yes. In some cases, we test things with small strings. Small strings behave differently than longer ones. Test things with both small strings and longer strings. Why? Because the bug would appear with either one, both, only one of them. Exactly. Can we, maybe can we improve this code by saying, you know what, maybe now we can do a get string that returns by value. Let's return by value. Returning by value in some cases is safer. So if the widget returns by value, is it right now? What do you say? What do you say? What do you think? Again, now the order is the issue. Now, if the call to move is being evaluated first, if the second argument is evaluated first, then we are in a problem. If not, okay, we got the copy on time, like Indiana Jones, like, before the door is closed. But it depends. I mean, it might work on a certain compiler and then would not on another, or flag or whatever. Okay, don't use moved from objects, or use them as you should, which is assigned to it or make it be distracted. Using a moved from object, no compiler warning, static analysis that didn't catch this thing, address sanitizer wouldn't catch it, especially with a small string optimization. A similar thing was caught in testing, and those who asked to be mentioned as contributors, I put the name on the slide for those who reported interesting bugs. How can we find it? In this case, testing, maybe code review. Okay, let's take another one. This one is a bit complicated. I will tell you what is the story. The story is the complicated code that I'm trying to put into one slide tried to register a factory per type. So there is a type, and the type wants to be registered, and the way the code tried to register each type only once with a factory was to create, if you see the assume single thread comment right below, there is a static variable inside the function which would be initialized only once per type. So if we are going again to register factory with the same type, the static variable will not be initialized, so we will not call registry insert. So in a way, we try to make sure that registry insert would be called only once by assigning that to a static variable. And the issue here was that C wanted to be registered and C wasn't registered because C was a type def, was not an actual type. And there was a need to register C. Now, one can say, okay, it works as designed. Yeah, it means that the design is faulty. It means that we wanted something which didn't work for the scenario that we needed. What would you say about the entire thing? Probably the model selected is too complicated, faulty. I mean, we started with something that in some cases wouldn't work. Non-compiler warning because it works as designed, can't be catched by compiler nor static analyzer because it works as designed. Testing, code review, and keep it simple. I mean, in a way, it was too complicated, like being too smart, too clever. Try to be, you want, maybe in main, register the types that you want to register one after the other. You see what you do. In some cases, this is the simple thing that actually works. And again, if you have another idea and it works and it is resilient to errors, that's fine. But think about what may happen. And again, this is inspired by a report by Ronen Friedman. What's the problem with this code? So that is not the exact example, but we can see here a few things. I can see here a few things. Yeah, somebody says it's too long. Single responsibility, I don't know, obj direction. We call obj direction, we take the obj and we return the direction. Direction, by the way, if we let's assume that we are doing a code review. What is your assumption about what is direction? It looks like direction is an enum, right? When we work with enums, one of the issues that may arise is that we try to convert enums and some value sneaks in, and now the actual value of the enum that we return is not the actual value that we wanted. Did you get something like that sometime in your career? You get the value of an enum that in a certain binary format, the value is important, not the enum, the value, and the value changed. Why? Someone just added an enum inside. So if the value is important, maybe we have to think about, maybe it's not an enum, maybe it's a class with, I mean, we have actual value, constructor value inside. And the entire thing is copy-paste, too complicated. I mean, can you see if there is a bug here? The answer is no. I mean, I should open the requirements. I should think what you tried to achieve here, and then go line by line in order to understand what is going on here. And code review, what would we say? Break it into functions. Add comments. Use temporary variables. In some cases, I personally like, it's a refactoring from the refactoring book. There is a refactoring technique of introduce a temporary variable. Why? Because a temporary variable has a name. So you do something, and then you take the result into, by the way, we have here xdiff and ydiff. They are valuable, but maybe we need something more that would assist in, and then maybe we need functions with names. So we call a function that has a name, so we understand what happens. And then we can even, if we have functions, this is quite complicated function, okay? So in order to make sure that it works, we need tests. If we break it into several functions, then we can test each one separately. And the value of testing each one separately is that if there is an issue, it is much easier to find the issue. It's much easier to check each part individually. Now, this comes from not the exact same thing, but from real code that looks like that. I mean, maybe you have something like that. The comments don't match. That is right. Yeah, the comments doesn't match. Like down right is down right, but left with right. If you can see, left on the top corner is when you return right. Right is when you return left. Something is wrong there. I don't know. I can't tell. Yes. There is no diff 00. Oh, yeah, yeah. I mean, we can sit here, I guess, for 10, 20 minutes and find a lot of bugs here. This thing was written to have bugs. But, you know, even if it was actually correct, we cannot tell. It's too complicated. And by the way, we would have more and more like that. More and more. Why? Because AI will write code like that. In some cases, not always. Maybe we'll tell the AI. Maybe we'll have a system prompt saying, but don't write ugly code. But as long as AI is willing to, by the way, there is a research showing that in the past 2 years, researching open sources, the amount of copy-paste is going up. The trend is up, and the notion is it might be related to AI. AI is more tending to add something instead of being like being like a structure into the current code. Anyhow, this is not something that we want. It continues on with another function, change direction. So we understand that the entire direction, which is a simple thing, but the entire direction is not managed correctly. So we need a refactor here. And refactor requires thinking about, okay, we need to first keep the current API, okay? Refactoring starts with, okay, we'll keep the current API, but we'll break the internal logic of the function in order to make it more simple. We'll add tests. Maybe we'll add tests before, just to make sure that we didn't break anything. And then maybe we'll have another model for that. But the first step would be, let's keep the public API, but change things inside. Because this code is bug prone. Now, in some cases, we go through bug-prone code during code review, and we have time pressure, and we have to check in. Do not check in something like that, even if it passes tests, because, oh, the bug would arise. And in some cases, we go through such code, and we say, okay, we don't touch it because it works. We just need to change something small. This is the case where you stop and say, we need refactoring. Unmaintainable code, this is the problem. Leads to bugs, magic numbers, there were a lot of magic numbers there. Bad use of enums, unclear, overcomplicated, and there is a logic issue. There is a very nice lightning talk. I don't think it is 5 minutes, maybe a bit more, by Mikhail Matrosov, refactor or die. And in some cases, you see code that you say, okay, there is a probability of a bug, and the probability is, let's say, 0.001%. And then it goes up. And at a certain point, you say, there is a bug here. I don't know what is the bug, but I can tell you for sure, there is a bug here. So it is refactor or die. And when you do refactoring, you can keep the API and make sure that it works as expected without changing the API. This is the idea of refactoring. What's the problem with this code? I mean, you can say the same, but I mean, there is a direction here, something specific. Too much nesting, yes, too much nesting. What is the purpose of all this nesting? What are we trying to achieve? What are we trying to manage here? There is a request that needs to be processed, and the processing logic is conditioned upon a state. There is some kind of, oh, there are different states, and in this state we should do something, and in another state we should do something else. And the way to check which state we are in is to manage the state together with the logic in one big, ugly function. What should be the actual way to handle states? With the state pattern, or if we move from one state to another state and the logic changes, with the state machine. So when we see a state hell, we should refactor that to a state machine. And state management is much easier being maintained as a state machine. State machine is a better way to manage complicated states because we separate the question of which state we are in, and we have the logic of switching between states. And once we know which state we are in, the logic is quite clear. And usually the logic is easy to find in the requirements. You say, okay, if we are in this state, what should we do? Okay, the requirements actually say that. So we'll not have the bug of, oh, we did something that is not related to this state. No, we see, we are in this state, this is what we should do. Like you are in a cancel state, or you are in a terminate state. You shouldn't do the things that you do if you are not in a cancel state. So yes, let's separate them. Now, when we separate them, in some cases we feel bad because in some cases we duplicate code. The code in the cancel state, maybe we could, with a sophisticated if, put this in the, no, call a function. I mean, yeah, both would call some function because both in cancel state and in terminate state, we need to do something, okay, we'll have a function. But we do want to see them as different states. Otherwise, bugs. Other significant issues. API issues. API that is not working is documented. Why? Because, excuses, things. How do we deal with that? I mean, we usually, we trust the API that we're using. So let's assume that we have test, okay, our test. Our unit test work. When we unit test, do we work with the external API? No, we use mocks. So if our unit test works, but when we come to system test, Now we say, okay, there is a problem. Okay, the unit test worked. With the actual API, something is wrong. Okay, let's go to the logs. But we need to test that. And then we realized, okay, something is bad with the API. Should we write test for the API? Usually no, because it's an external API. We are not paid for checking API of others. But in some cases, yes, I don't know, it depends. But one thing for sure, we should never assume that the API works, because it might not. And then if the plane crashes, we cannot say, oh, it was because of that API. I mean, we would say that at court, but in court, but I mean, we don't want to reach there. I mean, it's not us who would say, somebody else will go there. API, assuming API behavior which is not documented. In some cases, we say, oh, this is how it works. Okay, where is it written? Oh, there isn't any documentation. We just, there was a discussion, this is how it works. But then it may change. I cannot rely on something which is not documented. I mean, I can go to the actual function and see, okay, it is implemented like that. But again, when we get the new version, if it is not documented, then it may change. Don't rely on anything which is not part of the documented behavior. Bad argument sent, wrong order, type mismatch, leading to undesired casting, wrong measurement units. How do we deal with that? Strong types. But maybe the API is not working with strong types. The API get distance. Which measurement units? I don't know. Let's check. Let's ask them. Oh, they are using, I don't know, legs. Okay. Nautical miles. Okay. But we are using meters, let's assume, or any other. Okay. What should we do? Let's use I don't want to call the API because the API doesn't use strong types. I mean, it uses numbers, 7. What does the 7 mean? Nautical miles. Okay, we don't work with nautical miles. I don't know. I won't work with my measurement units, which do have actual types for them, but this type doesn't fit the API. What should we add on our side? It's a design pattern. A facade, maybe. A facade that would work between our code and the code that we say, those, I don't know the word. I know the word, but I don't want to say it. So, yeah, I don't want to call the other function which I don't like or which I know that they are going to change the API or the API is not good enough. I can call my API, which would be the facade, and then in the facade there would be some, okay, we know in the facade that they are expecting nautical miles, let's say, and we got an actual distance object. So we call on the distance object, get nautical miles, we get an actual number. We don't want to work with numbers in our code. I mean, in our code, numbers is only maybe for looping, and then even when you want to loop, use STD algorithms, or for each. But, okay, if you work with something that has a meaning, it should have a type. Not handling error cases, ignore return value. Okay, the other side, in some cases, doesn't check something. What should we do? Which design pattern can we apply? A facade. We can check things before going to the API. I mean, okay, the API takes things, the API returns something. Oh, it returns something that doesn't work. Maybe I can check that the return value is within the appropriate range before taking that and saying, okay, we got it from a trusted API, let's use it. No, wait. Let's first check that it is within the appropriate range. Should we check it anywhere in our code? No, let's check it once in the facade. So let's not trust something that we cannot trust. Make sure that it actually works as we assume. By the way, should we have a facade for the other team in our company? I mean, they're good people. I don't know if you trust them, but they're good people. Should we have a facade for the other team? My answer is yes. Yes. In the projects that I was working on and we add facade for the other team, it saves, fighting in the corridor. Less violence. Much less violence. I mean, something is being changed by the other team, no worries. We'll change it in the facade. And less bugs, eventually. So facade for sure is relevant for external code. but also for external code is also the other team, the other component. Mitigations, we said testing, add unit tests, read the manual, and protective programming. Other significant issues, bad memory access, invalidated iterators, like for example, we hold an iterator to a vector and then we call pushback and then we use the iterator, right? We don't do that, but somebody else in our company does that for occasionally. And sanitizer may find it, but sanitizer may not, by the way. Let's assume that we run a test. Again, the scenario is, we take an iterator from a vector, we hold it, we call pushback. Now pushback may be beyond the capacity, then there is a new allocation and the iterator is invalidated, right? And we hold now an invalidated iterator and we try to use it. Now, it might be that in our tests, we don't see the actual problem. Why? Because the call to pushback in our tests didn't enlarge capacity. The capacity was big enough. In our test, it was big enough. Okay, so you need more tests. You need to make sure that, okay, I want to make sure that even if I call not one pushback, many pushbacks. Because in production, it will pop up. I mean, the invalidated iterator would be invalidated at a certain point. I mean, those are the most nasty bugs. Those that, yeah, it worked on my machine, it worked in the test, usually it works. I mean, oh, it happened in production, but only once. Probably a problem with the server there. Or we had an invalidated iterator. Using vector iterator stored before erasing, same thing. I mean, when you store something, before you use it, think, is it still valid? Dangling reference, invalidated iterator, moved from object. In some cases, static code analysis would help. In other cases, I mean, all other cases, every time, just check. Ask yourself, in code review, in your own code. Accessing vector beyond size limits. I mean, it doesn't check for you unless you call, instead of the rectangle brackets, you call at. You can decide to call at to make sure that you will get exception instead. And testing. You get the idea that testing is important. The language is becoming more complicated than in the past. And I'm not the only one who is saying that. There is a very nice talk by David Sankel, C++ Now, is talking about the complication of the language. So I point you to a certain position in the video if you want, discussing things that change and make the language a bit more complicated. I will give you an example, okay? A simple example in the language. For each. Let's take for each and see the signature of for each on algorithm, that comes before NGIS, okay? And the signature is, there is an input iterator and a unary function. So I get input iterator first, input iterator last, and a unary function, right? Do you understand? I mean, the first one is quite simple. I can show it to students, I can explain the signature of the first function. The second one is much better signature, but much harder to follow and explain. Okay, it's the same for each, but for ranges, it's not exactly the same because the first and last might be different types, which I can understand. I mean, I don't want the last to be the exact same type of the first. Maybe it's a sentinel. Okay, that's fine. But let's see all those concepts. Input iterator I, sentinel for I, which is called S, a projection, which by default is the identity function or the identity type. Then an indirectly unary invocable on a projected I. How can we read that? Now, it is a good thing because I think API, which is more precise, is better than API, which is, I mean, too open. It says what we actually expect, but it is complicated. I mean, when you get such a signature, if you're a student, what would you do? Use the first one, right? So But the second one is the new one that you should use, because maybe you do have a Sentinel and you do want projection. So I don't know if we have mitigations here, but I think that frameworks might be complicated. That's okay. I think that we need to differentiate between user code and framework, even in the company. Okay, in the company we have this team that writes frameworks. There we have complicated signatures, something which is a bit more complex. But user code should be simple. And if simplicity comes with a price, I mean, oh, I could have used here a nice concept. If the concept helps me to understand, that's good. But if it complicates the code, maybe go with less complications, more maintainability. And of course, when things get complicated, what should you do? Always testing. Let's summarize. Programming is tricky. C++ might be even more. Mind the traps. There are traps. Not just because, you know, they are trying to trap us, but they are there. Be aware of the pitfalls, undefined behaviors, dangling references, slicing, but use the right tools to find them, and yet don't rely only on the tools. Be explicit. Prefer clarity over cleverness. Don't be too clever in user code. You need that in the framework. Okay, can you expose a simple API? Can you hide your implementation details so I will not have to bear in mind all these complications? Is it possible that I would not be aware that you are using inside a unique PTR? Maybe I will see value types. I will see objects. Oh, internally you use unique PTR. That's fine. I don't know about that. Okay, and then you can change it to shared PTR. And then, again, whatever I cannot use or it's hidden, less bugs. Be explicit, ambiguity and complexity, invite bugs. Prefer safe constructs. RAI. I mean, you don't have RAI because you need to call this function. Okay, wrap it with something that has RAI. Don't be, you know, don't try to avoid writing an additional class to wrap something that would bring RAI in order to make sure that, okay, at a certain point this object would disappear, would die, and there is a distractor. Smart pointers, strong typing, const expr. Use const expr when relevant, because const expr would assist in finding bugs as compilation errors. Small function, stateless is preferred over stateful. I mean, in many cases, we have a function that manages a state. And then I look at that and I say, okay, we can separate that into an algorithm which is stateless and something else that knows about the cache, that knows about the load balancing, that knows about, I don't know, that knows about the state. But the algorithm itself can be stateful. And in many cases, we just throw it all together in the same class, stateful and stateless, and the state is wandering around getting wrong values. So stateless is good. Stateless is easy to test. And many of the things that we do start with, okay, this is a stateless operation. Review and refactor. Do not get too much of a tech debt. Make sure to use the right tools. Compiler warnings. You saw the big list. I mean, at least -w all, -w extra. I like -w error. If I have a warning, I want to stop. But the list is longer than that. Static code analysis tools. Anyone who is not using a proper static code analysis tool, start today. Don't wait for tomorrow. You can, you know, go back to your hotel room and connect and do stuff. Runtime sanitizers in your tests. Now, when we run runtime sanitizers, they change in a way the code. So it might be that we would not go on a certain bug, but they do quite well. And my advice is to run sanitizers on both -0, no optimization, and the actual optimization that we run in production, because it's not the same code. Now, if we run it only on the optimized version that we run in production, it may not see some certain bugs that arise without optimization. So when you compile without optimization, some code that the bug is there, but maybe hidden, now will arise, and the sanitizer would find it. So my advice is to run sanitizer on both versions. Code review, of course. And when I say code review with a real showstopper, with real blocking power. Do you have code review that in some cases say, okay, you cannot push that? Or it's not the best, maybe we should fix it later, write a comment, but we are in a hurry, let's push it. If we always push, then code review doesn't have any real power. So eventually the programmer would come to code review without, having in his mind, in her mind, that, yeah, I can fix it later. No, that was a showstopper. And then we know that we need to come to code review after everything looks good and we understand that it actually works and don't have any code smells. Testing. You do testing, right? So do more. Because eventually the things that find bugs are mostly testing. And you remember, we started with accidental bugs and essential bugs. The essential bugs would not be found by static analyzers or warnings. I mean, an essential bug is that, oh, I didn't quite understand this requirement. I didn't know that. Now, it might be that the test also is not written well. So yeah, when I write the tests, I need to go with some product management. I mean, especially if it is there's a system test, integration test, and see that we actually run valuable scenarios that are in some reference to the actual live scenarios. Otherwise, we test something that is not relevant. By the way, BDD helps here, behavioral-driven development, where we write the test as given, when, then. So we write it as given, when, then, and the product manager can read that and say, yeah, it looks like what we actually want to test. That is almost the thing. Additional resources. I have a talk about typical type typos with some additional corner cases. I talk about enums. Enums is a source of bugs. I mean, be careful with enums. They look quite, innocent. They are not. Curiously recurring bugs at Facebook, a very good talk. Acknowledgements to those who fill out the form and gave a few examples. This is the form. If you want to share with me your own bug, I will be quite grateful. And then maybe I can add it to my next talk or publish it somehow. And we can learn all with, I mean, instead of learning only from our bugs, let's learn from other people's bugs. So we can do the same bugs again and then learn from our bugs. So take the QR and report bugs. It's a simple form. Just, this is the case, this is what happened, I found it in. If you want to get any attribution for that. And that is it, and I'm ready to take questions.
Yeah, so very interesting talk. So one interesting thing which I probably should provide in a form, but I just wanted to mention that one bug which I actually encountered in production is bit flip vulnerability. When basically our code expected certain state to be in one of the enum values, and there was no possible way of it being anything other than any of those enum values. And then if it wasn't, it just looped infinitely.
So it relates to an assumption that is not met with, the input or a security vulnerability?
No, it's basically what happened is the input was always correct. There was no way of it being incorrect. Security was fine. But something happened in production still. We had an infinite loop. And the only possibility I thought about, bit flip happened in my memory. And that variable wasn't what I thought it was.
And the source of the problem was?
the fact that basically we checked for this 4 values of enum, and we didn't have a default to just say throw an exception or something when it's not one of those.
Okay, yeah. So static code analyzers today require you to have, I mean, it depends on the actual rules that you apply, but require you to have a default for switch case on enums. And if you are with Mistra, this is a requirement. Yeah, so yeah, adding that is important. Any other bug that someone wants to I mean, not yours, something that happened with your colleagues in your team, in your company, somewhere else. Last year, by the way, I was about to come to CppNorth. I don't remember if you know, it might be that you remember that. There was a bug a few days before CppNorth last year. Do you remember that? We have a representative, by the way, here. I'm not sure that he's in the room. Maybe he's in the other room. I will not tell the name of the company, but maybe you can remember. And yeah, I hear the name here. And it seems to be something related to null, okay? And some air companies canceled their flights. And I had a flight with Porter, and Porter was canceling flights, and I didn't know whether I would be on time for the conference. And I think it was like 2 days before CppNorth, so a day was canceled, and luckily for me, I arrived for a flight that took off, so it was fine. But no plane crashed on the air. It was like only on the, I think, the ground systems or something. I don't know, they didn't provide any actual explanation, but the rumor is that there was a null pointer there somewhere. It still happens. And flights are being canceled and at least not being crashed. Yeah, Tom.
Thank you. Just a funny story, because you talk about null. 2 years ago at the school I work, our entire student administration system failed because we had a foreign student and his first name was null. Yeah, it's funny now, but it wasn't funny when he enrolled and nobody was enrolled suddenly and we didn't know who our students were. Fortunately, we had backups.
It might be that his previous name was Troll. This is my guess here, but it might be that this is a true name. I mean, the story sounds true, but checking for user input, this is something that we always need to do. Was it the JavaScript system? I mean, getting null as a string and using that as null sounds to me like JavaScript, but it can be anything. Oh, SQL. Oh, with SQL we can do many interesting stuff. Yes, yes. By the way, the things that I spoke about relate to both safety, but also security. Because if you do not apply the proper measures, then your system is not secured because it is open for vulnerabilities. Yes.
This is a recent bug that just happened to me. Remembering that views, particularly string views, are basically just fat pointers and their interaction with the small string optimization. And so if we had an issue where the string moved and almost everything worked fine because most of the strings were long, except for this one string, which was too short, was getting small string optimized, and then the string view was now pointing to something else.
So if I get it correctly, it worked when there is small string optimization. No, it didn't work with small string optimization. It worked when there is a location. Mm-hmm. Exactly. So things that moving parts is oh, it can work this way or the other way. Oh, it means that maybe in testing we tested only one branch, one moving part. So first of all, it is better not to have too many moving parts in our system. So small string optimization is good for performance, but it may hurt us if, okay, we relied on something, it works, we have a bug, But the bug will appear when, okay, now the string is small or big, and we didn't test that. And the best thing is, and maybe, is there any other question or comment? So I will tell you again, in order to feel safe, in this scenario, in any other scenario that we raise here, we need to go asleep and know that the system is fine. The best thing is, the crucial thing, the thing that we must have is testing. Testing. There isn't any other substitute. I mean, yes, static code analysis. Yes, all the warning flags that are required. Code review. Actual code review. AI review. AI does quite well with reviews. It points you at something is suspicious here, and you say, oh yeah, that is suspicious. But testing. Thank you.